For the first question, we're given a graph that looks like this, and we're asked to find whether it's even, odd, or neither. So from the graph, we can decide if a graph is even, or if a function is even, we define evenness as being symmetrical around the y-axis. So in this case, of course, we can see that. So graphically, we can see. If it were odd, we'd say that it has a 180-degree rotational symmetry. And then if it doesn't have either of those, then it's neither even nor odd. In terms of kind of algebraically what's happening is we can see that for any given input, A, the output, f of A, should also be equal to the output f of negative A. So we can see these points here as we move. They stay equal. And if we were looking at that, we'd see that the output's given. So f of A, whatever value, so for 2.5, if we look at 2.5 over here, we have this value, that's the blue line. And then for negative 2.5, we have this orange dotted line. And you can see that they maintain the same point. So this point, A, f of A, and then of course we'd have another point at A negative. So as we move, we can see that no matter where we go in our A value, both negative A, f of A, and f of negative A are equal to each other. So we know we have an even function. Then we're also asked, where is it increasing and where is it decreasing? So this function, what we want to think about when we're thinking about increasing and decreasing is, as x increases, what's happening to f of x? Okay. So as x increases, so here we have we're decreasing here. So as we're increasing, what's happening to f of x? And you can see that this black dot was climbing as we moved over. So we're increasing. We can see this tangent line here that gives the slope at that point. And that's also positive, so you know you're increasing. Then once we get to this point, we can see we're starting to travel down. So from negative infinity all the way up to, so we're talking about what input values we give. So from the input of negative infinity all the way up to the input of negative 2, we have increasing. Our function is increasing. And again, it increases from 0 to 2. And then it's decreasing from 2 to 0, and decreasing again from negative 2 to 0, and then it's decreasing again from 2 on to infinity. So we can get a sense of that. And then the last part of that question asks us to determine the local extrema. So of course we have a local minimum here at the point 0, negative 1, and we have two matching local maxima at negative 2, 3, and at 2, 3.